In this video, we are going to look at a couple of application problems related to linear equations. There's no way for me to give you an example of every type of linear equation that you could possibly see because there are way too many and this video would be way too long. So we're just going to look at three. Hopefully this at least gives you kind of a good idea of how to do a few things related to linear equations. So a lot of these, they'll ask us to write a linear equation to represent the scenario. They might ask us to solve for the two different variables involved, the y or the x. And so we'll see that as kind of a common theme throughout. So in the first one, Pam is an avid reader and wants to grow her collection of books. She decides to buy 3 new books each week for the next 2 years. She currently has 125 books in her collection. Write a linear equation in slope-intercept form to model this scenario. So slope-intercept form, let's just kind of write down, we know that that is y equals mx plus b. That's slope-intercept form. The m is the slope, the b is the y-intercept. And of course it doesn't obviously tell us what that is, right? It doesn't say, hey, the slope is this. But it does give us some information. Let's look and see what it gives us. It gives us 3 new books each week, and it tells us she currently has 125 books. What you're going to notice is that a lot of times, in this example or in another example, there's some fixed cost or a fixed thing that's already in place. In this example, that's the 125 books. That's already decided. She already has 125 books. The original amount is not going to change. So that's a fixed amount. Then there's a variable amount. And so in this case, the variable amount is how many books does she add to the collection, right? It depends on how many weeks have gone by because she's going to buy 3 new books per week, right? So the number of books she's adding to the collection varies based on how many weeks it's been since the start of her idea, right? Since she had this idea that she's going to buy 3 new books a week. So there's a variable amount and there is a fixed amount. We're going to be able to write the equation because the fixed amount is the b. That is the y-intercept. That's kind of where the starting point, you can think of it as that, is the fixed amount. The m is the variable amount. Okay, and that is how much it changes based on some variable, right? In this case, each week, it varies by 3 books, right? An additional 3 books are added to the collection each week. So y equals 3x plus 125. So let's think about what that means. We knew the 125 is the amount that she started with. 3 is the amount of new books each week. It's 3 books per week. So with that being said, that means x represents the number of weeks that have passed because it's 3 books per week, right? So it's 3 times the number of weeks. So x represents the number of weeks. If we plug that in, then we're going to find the number of books she has after that many weeks. So this y is going to give us the total number of books she will have after so many weeks. Okay, so once you write the equation down, kind of think about it and figure out what your variables are representing. That will help you answer the following parts. So part A is done. We had to write a linear equation. Here it is, right? The linear equation that represents that scenario. Now we're going to use that equation to answer some questions. So part B, how many books will she have after 17 weeks? So the weeks, we just have to figure out where we're going to plug the 17 in. That's what it boils down to. Is X or Y? X represents the number of weeks. So that's where we're going to plug in the 17. So this will be, this will be y equals 3 times 17 plus 125. When we figure that out, we will see that 3 times 17 is 51, and 51 plus 125 is 176. So she will have 176 books after 17 weeks. Okay. Part C, how long will it take Pam to accumulate 230 books? So again, they're giving you a value. You just have to decide if that value should be plugged in for Y or X. So Y is the total number of books. So 230 will go in for the Y. So we'll have 230 is equal to 3x plus 125. And once you have that plugged in, you'll see that you need to solve for X. That'll tell you how many weeks it will take for her to get the 230 books. So to solve, we need to undo the addition first. So minus 125. Okay, so 230 minus 125 is 105, and that will equal 3x. That's 3 times x, so to undo multiplication, we divide. So 105 divided by 3, and that will give us x equals 35. So it will take 35 weeks for Pam to accumulate 230 books. All right, let's look at another one. So before I start number 2, I will just point out I used 2 different books for reference to find these word problems. So one of them is the Open Text Bookstore. It is Math and Society by David Lippman. That one I got a couple of these from, and then I also got an example from the OpenStax textbook. So both of these, the URLs are there. Feel free to check them out. All right, number 2. The population of elk in a national forest was measured to be 12,000 in 2003 and was measured again to be 15,000 in 2007. Assume the population grows linearly. Write a linear equation in slope-intercept form that represents the scenario, and then there's a follow-up question. So first let's try to figure out how to write this in slope-intercept form. So in this one, it doesn't really give us like a variable rate and a fixed rate. It gives us 2 kind of data points. And if you think about it like that, 2 data points, when you think of a point, you think of an ordered pair. And that's kind of what it's giving us here. Notice that the first measurement was taken in 2003. Let me use a highlighter here instead. So this first measurement was taken in 2003. And then another measurement was taken in 2007. Okay? So you can think of this in this way. A lot of times when they're giving you a year, they have what's called a base year. Okay? A base year is the original or first year something happened. Okay, in this case, the first year was 2003, so that's considered the base year. That means 0 years have passed. So if your first measurement is in 2003, the amount of time that has elapsed since 2003 is 0. In 2004, let's say you took another measurement in 2004. You could say the time would be 1, because then 1 year has passed since 2003, because that's the base year. You're always looking back to the base year. So if we look at this ordered pair, we're going to have the number of years. And the other thing you want to, let me stop. You want to think about which one causes the other to vary. So the elk population varies based on how many years it's been, right? You assume that either the elk are flourishing and they're multiplying, and so there will be more elk each year. So each year you measure, the elk population will increase. Or it could be another scenario where they're dying off, they're not reproducing as much as they are dying, so it's decreasing, right? So kind of the number of years that have passed since you've measured will allow you to see this change in the elk population. So the X value that you want is going to be the number of years that have passed since 2003. And then depending on how many years it's been, that will cause a variation in the population. So the population of elk, that will be the Y value. Okay, and so in this case, this first measurement is 0 because 0 years have passed since the base year. And there are 12,000 elk. Okay, so that's the first one. That's the highlighted in red. That's the 12,000 elk in the year 2003. In 2007, okay, so in 2007, how many years has passed since the base year of 2003? You simply find that by subtracting. So 2007 minus 2003 is 4 years. So that's 4 years later. So 4 is the X value. It's been 4 years since the original measurement. And the new measurement, the population of elk, is 15,000. So we've got 2 data points, okay? 2 data points. Whenever we're writing the equation of a line, we have to have a point and a slope. A point and a slope. So we have 2 points, but we don't have a slope. But remember this formula for finding a slope? So I'm going to erase this part. The formula for finding a slope is y2 minus y1 over x2 minus x1. So if we have 2 points, we can find the slope. And so that's what we want to do here. And so I'm going to make the second point be my 2's, right? So this will be x2, y2. And the first one will be my 1's, and then I'm going to plug those in. So y2 is 15,000 minus y1 is 12,000 over x2 is 4 minus x1 is 0. And so now we can subtract, so we will see that this is 3,000 over 4. And then if we divide that out, we will get 750. So 750 on average, let's think about our units here. The Y's, that's the population of elk, right? The X's is the number of years. So if we divide this out, what this is saying is that on average, the population of elk increases by 750 each year. Okay, so there's an increase in the population of elk each year by 750 elk. If the number was negative, if it had been a negative 750, then that means the population is decreasing each year, right? So the sign of the slope is kind of telling you if your population is increasing or decreasing. Okay, so now we have a slope, we have some points. I'm going to use this point. This point 0, 12,000. Because what's special about this point? If you hadn't noticed yet, the X value is 0. Remember, if the X value is 0, that this is the Y-intercept. And that makes it very easy to write an equation. Remember, we can just jump right into the y equals mx plus b form because it gives us the b, right? The 12,000 is the b. So I have the slope. It's 750. That goes in place of the m. And then the b is 12,000. So there is our equation. So this one was a little bit more complicated, or maybe not complicated, but you had to do a little bit more work to get to the equation than you did in the previous one. And that's because we had to find the slope first. All right, part B. What will the elk population be in 2014? Okay, so be very careful with this. First of all, we need to figure out, are we going to be plugging our number given into the X or to the Y? you can see that the X value is the number of years since 2003 and the Y value is the population of elk. So we want to plug this in to the X value, right? But be careful here because a lot of times students will just take the 2014 and they're like, oh, there it is. And so what they do is they just say Y equals 750 times 2014 plus 12,000. And hopefully you see the fallacy, right? The error here. The error is that X is not the year. X is the number of years since 2003. So this is not correct. It's going to give you a crazy large number. To find the X value, remember that you have to take the year that you're looking at and subtract the base year. And our base year was 2003. And so when we subtract, we will see that the X value is 11. And so that's actually what we want to plug in. So we would have Y equals 750 times 11 plus 12,000. So 750 times 11 is 8,250. And then we would add that to the 12,000 and we would get 20,250. So that would be the elk population in 2014. So be careful when you see years. A lot of times what you want to do is choose a base year and look at the time that has passed from the base year rather than the year itself. All right, our last example for this section, number 3. A telephone carrier offers a plan in which they charge a monthly fee of $20 in addition to a charge of 5 cents per minute. Write a linear equation in slope-intercept form that represents this scenario, and then there's a follow-up question for part B. So first, take a few seconds or a minute or however long it takes to look back at the first two and see which one you think this is more closely related to. So if you're looking, you want to kind of look and see, does it give me a variable and a fixed amount, or is it giving me 2 data points to use? And in this one, it's giving you a variable and a fixed amount, right? We have a fixed amount. No matter how much they talk, the customer is going to be charged $20 a month. So if you never use your phone, you're paying $20. If you use your phone a whole bunch, you're going to pay the $20 and then a charge per minute, right? And so that brings us to the variable cost. There's a variable cost here. Whoops, let's do blue. The variable cost is 5 cents per minute. Okay, so we're going to use that information to write our equation. So Y equals, the variable cost is 5 cents per minute, and then the fixed cost is $20. The X represents the minutes, right? Because again, remember, it tells you here, it's 5 cents per minute. So per minute means the X is the minutes. So then Y, if we plug in the number of minutes and we combine this stuff together, that's going to tell us how much they're going to actually pay. So this is going to be the total charge. All right, so we've got the answer to part A, but I just wanted to take a second to kind of talk out what the variables stand for. All right, part B. Last month, a customer was on his phone for a total of 1,250 minutes. How much can he expect to pay? So now your goal is to figure out, well, where do I plug in the 1,250? Since the 1,250 is minutes, that goes into the X, right? X stands for minutes. So we will plug that in. So 0.05 times 1,250 plus 20, and that will give us the amount the customer will pay. So 5 cents times 1,250 minutes, that's $62.50. And then plus the $20, so that will give us $82.50.